Today's topic 4 is going to be on the periodic table and periodic properties, that is periodicity. I'm very sorry for the long break in the channel. I've really not posted a lot of videos for a very long time right now. I'm very sorry. Please forgive me. Please. It's because of school activities, and I've not really had the time to balance everything. But still, that's not an excuse. That we're on holiday actually, although I'm still in school. So I want to just use this opportunity to make as many videos as I can before we resume again and everything starts coming up. But I'm very sorry for the long break. Please, apologies. Do well to enjoy the video, and don't forget to like, subscribe, and share.
Okay, so introduction to the periodic table. Now, classification of elements started with a man named Lavoisier, who classified elements into metals and non-metals. Now, but around 1869 to 1871, Dmitri Mendeleev created the periodic table. So he also propounded the periodic law, which states that the properties of elements varied with their relative atomic masses. That is, his periodic table was in order of increasing atomic masses. He also predicted some elements, and these elements did not only fall in its predicted positions but also had its predicted properties. This is what Mendeleev's periodic table looks like in order of increasing atomic masses. Now, due to some limitations of Mendeleev's periodic table, it had to be modified. A good example is the issue of isotopes. Since it was based on increase of atomic masses, now these three isotopes of hydrogen, protium, deuterium, and tritium, will be classified as different elements on the periodic table since they had different atomic masses. So to correct this, the atomic number was then used. This led to the modern periodic law, which states that the physical and chemical properties of elements are periodic functions of atomic numbers. The major change here is classifying elements based on atomic numbers instead of atomic masses, and this corrected the limitations of the Mendeleev's periodic table. And this is how the new periodic table looks like. So the verticals are called groups, while the horizontals are called periods. Group number is the number of valence electrons in the outermost shell, while period is the number of shells. Okay, so if you take a sample element, let's say sodium, its group number is 1, its period is 3. You see, it falls in the first vertical column and the third horizontal row. So its group is 1 and the period is 3. So group number is the number of valence electrons, while period is the number of shells. So if we draw its electronic structure, you can see that the valence electron, the electron in the outermost shell is just 1, therefore group 1. And you can see that it has 3 shells, and that means it falls under group 3. Okay, so note that sodium has the atomic number 11, so that's what we use to draw the shell. Okay, let's try another example. So if we bring out neon from this last group, this is group 0 and period 2. Now you'll be thinking, what? Group 0? Does it have 0 electrons in the outermost shell? Well, no. These elements have their outermost shells complete, and so they are regarded as group 0. So neon has the atomic number 10, so we use that to draw the electronic structure. You can see that the outermost shell, which has maximum of 8 electrons, is fully complete right now, and so it is group 0. And then it has 2 shells, so period 2. So we count 1, 2, 3, 4, 5, 6, 7, and 0. Now you notice I omitted these middle guys. These are called the transition elements, while these guys are called the inner transition elements, which came from here. Now, group 1 elements are called alkali metals. That is, their oxides dissolve in water to form basic hydroxides. That is, the hydroxides act as base. Now, group 2 elements are called alkaline earth metals. Now, for group 3 elements, now oxides of aluminium and hydroxides of aluminium are amphoteric. That is, they behave sometimes like a base and sometimes like an acid. Now, group 4 elements, so they're in between the metals, which is from group 1 to 3, and the non-metals from group 5 to 0. So they behave in between. Now, here's what I mean by they behave in between. Okay, let's take carbon for example. Since carbon has 4 electrons in the outermost shell, it can give out the 4 electrons to be a stable duplet. It can also take 4 electrons to make the outermost shell complete of 8 to be a stable octet. Okay, so it can either give or take. But if we bring oxygen, a non-metal from group 6, which has 6 electrons in the outermost shell, it can take 2 electrons to be stable, to be a stable octet of 8 electrons, but it can't give out 6 electrons. You get? But if we take a random metal such as aluminium, which is from group 3, it can give out 3 electrons to be a stable octet. Yeah, to be a stable octet, but it can't take 5 electrons. So you see that the metal such as aluminium is only a donor. It only gives out. The non-metal oxygen only takes, but carbon can do both. That's why I said it behaves in between. So group 4 contain metalloids, that is semi-metals, that is in between a metal and non-metal. But there is a funny group trend in this group. Group trend means the variation of properties as you move down or up the group. Okay, so if you look at carbon is a non-metal. Then silicon and germanium are metalloids, that is semi-metals, and then tin, which is Sn, and lead, Pb, are metals. So you can see that as we move down the group, the metallic character is increasing. So carbon, it was a non-metal. Silicon and germanium, it becomes semi-metal, and then at tin and lead, it becomes fully metal. Okay, so this group are the group 5 elements. N stands for nitrogen, P for phosphorus, AS for arsenic, SB for stibbium, now popularly known as antimony. So stibbium is the Latin name. And what's Bi? Bingo. Okay, Bi is bismuth. Okay, so these are group 6 elements. We have oxygen, sulfur, and so on. So they are basically non-metals. So from group 5 down to group 0, which is the last group, they are non-metals. Okay, so these are the group 7 elements. We have fluorine, chlorine, bromine, iodine, and so on. So they are called the halogens, which means salt formers. They normally form salts. That's why in your table salts, or what they call common salts that you use at home, is sodium chloride, that is contains chlorine. See why they call them salt formers. So here are some properties of the group 7 elements. Now, here are some properties of group 7 elements. They ionize to form univalent negative ions. That is, they collect only one electron and therefore they become -1 or just a minus. So you see, these are their shells are 7 electrons in the outermost shell. So you need just one electron to be complete. That's why they form univalent negative ions. That is, negative ions of the charge -1. That's what it means. So you need just one electron to be complete. Now, the second property is that they exist as diatomic molecules. What do you mean by molecule? That is, when the atom is on its own, they exist in groups of 2. So fluorine, chlorine, and bromine, you see them, 2 atoms making up one molecule. So when they are uncombined, they don't exist alone, they exist in group of 2s. Now, third, they are colored. That is, fluorine is yellow, chlorine is greenish yellow, bromine is reddish brown, while iodine is black. Now, group 0, we have helium, neon, argon, krypton, and xenon. Now, you can see that this is the shell of neon. For example, you can see that the outermost shell is complete. So usually they don't go into chemical reaction because their shells are complete already. The reason why atoms go into chemical reaction is to form a stable shell. So that's why they are called the inert gases. Now let's go to periodicity. Periodicity is the change in properties of elements as we move across the period or down the group. So just like we spoke in the carbon family. So here is one example of periodicity: melting and boiling point. Across the period, it increases for metals but decreases for non-metals. That is, as we move across the metals, group 1 to group 2 to group 3, melting point increases. For non-metals, group 5, 6, 7, it decreases. Now down the group, it decreases for metals. That is, for metal groups, the melting and boiling point decreases as we go down the group. But for non-metals, the melting and boiling point increases as we move up the group. Now, ionization energy. This is the energy needed to remove electrons from the outermost shell of an atom. So the lower the energy required, the more tendency to lose electrons. So what metals and non-metals, which has more tendency to lose electrons? Metals, right? So the ionization energy is usually lesser in metals than in non-metals. Non-metals have very high ionization energy, so they need much energy to give out their electrons. Okay, so you can see that as we move across the period, that is from metals to non-metals, ionization energy increases because the non-metals have higher ionization energy than the metals. So higher energy means less likely to give out electrons, but ionization energy decreases down the group. So it increases across the period and decreases down the group. Now third, we have electrical and thermal conductivity. Now metals are good conductors, non-metals are poor conductors. So as we move across the period, that is from metals to non-metals, you can see that conductivity will reduce since we are moving from metals to non-metals. So down the group, conductivity will increase. So you can see that anything that increases in group must reduce in period. Whatever increases in period will reduce in group. Now atomic radii is number 4. This is the distance from the nucleus of an atom to the outermost electron. If you remember in your mathematics, radius. Okay, so now it is a term used in chemistry to describe atomic size. So a larger atomic radius means a larger atom. So as we move across the period, let's pick 3 elements from one period: lithium to carbon to oxygen. You can see that atomic radii decreases. Okay, so atomic radii decreases across the period but increases down the group. This is due to a phenomenon called nuclear charge. Now let's go to diagonal relationships. Okay, so we know that let's zoom in first. Let's give an example. Okay, so now as we zoom in, let's use atomic radii for example. So now as we move across the period, atomic radii will be decreasing, but as we move down the group, atomic radii will be increasing. This causes a diagonal resemblance. So this is what we call diagonal relationship. So a popular examples are with lithium and magnesium, beryllium and aluminium, boron and silicon. This makes them share similar properties. Okay, so now let's go to chemical bonding. Okay, that is atoms coming together to form compounds. Now the first one is ionic and electrovalent bond. So it's when a compound is formed by transfer of electrons from the metals to the non-metals. So it's a kind of bonding that occurs between metals and non-metals, in which the metal loses electrons to be stable, while the non-metal collects the electron from the metals to be stable. So metals are donors, non-metals are acceptors. Now we have aluminium and nitrogen as an example. So aluminium will need to give out 3 electrons, so that its next shell will now be 8 electrons, that is complete, that is full. And nitrogen will need those 3 electrons to have 8 electrons in its outermost shell, since it has 5 now. So this is how ionic bond works. So aluminium loses its 3 electrons and nitrogen accepts them and becomes stable. Simple ionic bonding. But a lot goes on here. Let's go back. Let's turn the clock. Okay, let's go back. Now, before aluminium went into bonding, now the atomic number of aluminium is 13. So the number of protons is 13, the number of electrons is also 13. So the charge of protons will be plus 13, while the charge of the electrons will be minus 13. Now the total charge of the protons and the electrons will make aluminium to be 0. Now, for nitrogen, the charge of protons is 7, charge of electrons is minus 7. But now, as aluminium loses 3 electrons, it makes the charge of the electrons drop to minus 10, making the total charge to be plus 3. So aluminium has become an ion of the charge plus 3, therefore a cation. This is positive charge. And now, nitrogen accepts those 3 electrons, making the electron charge to increase to minus 10, and therefore gives it a total charge of minus 3, and therefore nitrogen is an anion, since a negative ion of minus 3. Other examples are for sodium chloride and calcium oxide. Now the quest is that you should try this on your own and try to explain them in the comment section, and I will review it. Now, properties of ionic bond. Number 1, they do not consist of molecules but aggregates of ions, just like we saw in the example. So they don't bond together as shape of molecules but group of ions forming crystal lattices. Now number 2, they are solids and do not vaporize easily. 3, they have high melting and boiling points. 4, they dissolve in water and other polar solvents. 5, they do not dissolve in non-polar solvents. 6, they are good conductors of electricity in molten and solution states. Now you can screenshot that to memorize. Now 2, covalent bond. This is a bond formed by sharing of electrons. Now if we see in the hydrogen molecule, since hydrogen molecule is diatomic, now that is 2 atoms of hydrogen come together to form the hydrogen molecule. Now since it's the first shell, both of them need to be 2 electrons to be complete. So when they come together like this, the purple hydrogen atom will allow its electron to also be on the shell of the other hydrogen atom. Same, the hydrogen atom with the yellow electron will allow its electron to also fall on the shell of this other one. So if you look at the shell of only one atom, you see that there are 2 electrons. If you look at the shell of the other one, you see that there are 2 electrons. So they are not totally giving it out, they are sharing. So since both of them contributed one electron. This is called a single bond and it's shown like this. Now we have the water molecule, in which two hydrogen atoms combine with one oxygen atom. Now these two hydrogen atoms need one electron each to be stable, while the oxygen needs 2 electrons to be stable. So you know how this will work. The two hydrogen atoms will be joined with the oxygen atom in this manner. So this way their shells overlap. So if you look at the hydrogen atom at the bottom, you see that if you look at only his shell, there are now 2 electrons. If you look at the one at the top, you see that if you look at only the hydrogen shell, there are now 2 electrons. If you look at the oxygen shell now, you can see that the electrons are now complete. So it's a kind of bonding, sharing. I allow my electron to be on your shell and you also allow yours to be on mine, but I don't totally lose my electrons. So this is a kind of bonding by sharing, so in which both of them become stable without totally losing their electrons. Now since both of them contributed one electron each to the bond, this is called a single bond and is represented by one dash. Okay, so we have the oxygen O, we have the hydrogen H, represented by one dash. Now double bonds is 2 dash. You can see in oxygen molecule and carbon dioxide. Now triple bonds we use 3 dash, as I say in the nitrogen molecule between nitrogen and another nitrogen atom. We also have coordinate covalent bond, a type of covalent bonding in which the shared electrons are only contributed by one atom. Okay, so as we can see in the combination of the hydrogen ion and ammonia forming ammonium ion. So you can see the hydrogen ion is formed when one electron of hydrogen has been lost. So that's why you can see that it's just an empty shell. Okay, so when you lose one electron, it's +1. That's why the hydrogen ion is like this. So you can see that the hydrogen ion needs 2 electrons in that shell to be stable. So the hydrogen ion shares 2 electrons of the nitrogen to be stable. So if you look at only the hydrogen atom shell only, you see that it has 2 electrons now in its orbit, but does not totally take away those electrons from the nitrogen. So this is a form of sharing, but the electrons only contributed from one atom. So you draw the structure like this: nitrogen at the middle, the 3 hydrogen atoms, and then the one representing the coordinate covalent bond, we use an arrow pointing towards the hydrogen to show that only nitrogen contributed those electrons. Now we also have hydrogen ion and water forming the oxonium ion. You can see here that the arrow is pointing towards the hydrogen that accepted those electrons. Now properties of covalent compounds. Covalent compounds can be solids, liquids, or even gases having different molecular shapes. You can see that we drew different shapes for the molecules just now. Now 2, they have low melting and boiling points. Now 3, they dissolve in non-polar solvents like benzene and toluene. 4, they are poor conductors of heat and electricity. Hydrogen bond. Now hydrogen bond is found in the molecules of compounds that are formed by a combination of hydrogen and highly electronegative elements of small size. Okay, forget about definition. But hydrogen is bonded to elements like oxygen, nitrogen, and fluorine. Now, what happens is that in the molecules of this compound, let's use water for example, hydrogen and oxygen. In the molecules of this compound, the hydrogen bond occurs as an attraction between the hydrogen of one water molecule to the oxygen of another water molecule. So you can see the attraction between the hydrogen of one water molecule towards the oxygen of another water molecule. This is what we call hydrogen bonding. Now let's see in the case of hydrogen fluoride, that is hydrogen and fluorine. You can see that the attraction is between the hydrogen of one hydrogen fluoride molecule towards the fluorine of another molecule. So this is the order of decrease in hydrogen bond strength. Hydrogen bond strength with oxygen is stronger than nitrogen, and that of nitrogen is stronger than fluorine. Now we have metallic bond. This is a kind of bond found in metals in which the metal atoms donate their valence electron to form an electron cloud. Okay, so let's say lithium atoms now. Now these are all lithium atoms. Now how the metallic bond works is that they will all give out their valence electrons, forming an electron cloud. Now since they have given out their electrons, they are now positive, and their electron cloud is negative since it's made of electrons. So the positive atoms will be glued with the negative electron clouds flowing all around. So this is how they form the metallic bonding. So it's a kind of attraction, electrostatic attraction between the negative electron cloud and the positive atoms. Now let's go to Van der Waals forces. Van der Waals forces are formed when already created molecules makes itself polar, that is, it makes one side negative and the other side positive. Let's say this is a molecule that must have been formed with anything, we don't care, maybe even covalent bonding. So it makes one part of it positive and one part of it negative. So in the presence of other molecules, you can see that they'll be able to attract one another because of that, to hold the different molecules together. So this is what we call Van der Waals forces. Now in the next video, we'll treat nuclear chemistry and also past questions, and that will be the end of the topic 4.
Thanks for watching to the end. If this is your first time on the channel, my name is Wisdom Richman. I'm a petrochemical engineering student of the Federal University of Petroleum Resources here in Eforo, and I make chemistry videos. Okay, so currently I'm on the Jamb series, so do well to subscribe so you'll be notified anytime I post a new video. God bless you.